Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 14.2, which is going to do with the law of cosines. So in section 14.1, we talked about the law of sines. Today, we're going to be taking a look at the law of cosines. Now, for today's lesson, we have one learning goal, and our learning goal for today is that you will be able to use the law of cosines to find angle measures and side lengths. So we're going to talk about what the law of cosine is, and then use the law of cosines to help us find unknown angle measures and side lengths. So similar to what we did in 14.1 with the law of sines, just this time we have a different situation and a different law to use. So with that said, let's talk about the law of cosines. So the law of cosines states for triangle ABC, the law of cosines states that a squared equals b squared plus c squared minus 2bc times cosine A. So law of cosines is a pretty extensive theorem, but it is an extremely helpful theorem, and it's really just about plug and chug once you put in all of your information. So you can do the same thing whether you're trying to figure out the length of side A, B, or C. It doesn't matter. It just alters the letters that you use. So to figure out the side A, it's a squared equals b squared plus c squared minus 2bc times cosine A. I know that kind of gets smushed in here, but that's 2bc times cosine A. So to figure out B, it's b squared equals a squared plus c squared minus 2ac times cosine B. And then to figure out side C, it's c squared equals a squared plus b squared minus 2ab times cosine C. So a few things to note is when you're trying to find a side length, whether A, B, or C, okay, so let's say we're trying to figure out the length of B. You need to use the measure of side A and the side C, and then we're going to use the cosine of the angle opposite the side we're trying to find, which in this case is side B. Okay, if we were trying to figure out side C, we would use cosine C, side A, cosine A. So whatever side you're trying to use, you need to use the angle opposite to help you figure it out and to use the law of cosines. So these three right here are what you're going to use to find side lengths. If you're trying to find angle measures, you're going to use, this is just a variation from all three of these, but let's say we're trying to figure out the measure of angle C. It's cosine C equals c squared minus a squared minus b squared all over negative 2ab. So if I'm trying to figure out the measure of angle C, okay, we're going to start, you have to know all three side lengths to do that. But if we're going to try to figure out the measure of angle C, we're going to start with the side opposite. We're going to subtract it by the other two sides, and then divide it by negative 2, and then the other two sides. So that is going to be our goal for today and what we're going to use. So the law of cosines, this is the main part of the law of cosines, and then this is a variation of the law of cosines to help us figure out angled measures. So with that said, let's get into example 1 for today. Alright, example 1 is going to state, solve each triangle, find the measures of the missing side lengths and angle measures. So much like we did in 14.1, we need to go through and find the missing measurements. Now, if we look at example 1, part A, we have triangle ABC. We know that the measure of angle B is 100 degrees, and we know that side C is 5 units long, and that side A is 7 units long. So we know one angle measure and two side lengths. Now, with the law of sines, my preference was to go through and figure out angle measures first. But for the law of cosines, to be able to figure out the angle measures, you have to know all three side lengths. So if we look at A, we only know two side lengths right now, 5 and 7. So we need to figure out the length of B before we can go through and figure out the measure of angle A and the measure of angle C. So we're going to use the law of cosines. We're going to use the B part. So that is where, I'll pull up my completed notes. So we're going to do B squared equals A squared plus C squared minus 2AC times cosine B. So we start with B squared. That's going to equal, then we're going to take the other two sides that we know the measure of, which is 5 and 7. So it's going to be 5 squared plus 7 squared. And then it's going to be, so we filled out that first part, this A squared plus C squared, then it's minus 2AC, so it's minus 2 times those other two sides. So minus 2 times 5 times 7 times cosine B. So times cosine, and then the measure for angle B is 100. So cosine 100. So I realize, okay, that looks messy, terrible, awful, in all the sorts. But once you get everything plugged into the formula, it's just about going through and calculating and then getting your answer. So let's go ahead and go through and start calculating this. So we're going to go through and plug this whole entire thing into the calculator. Hopefully your calculator can handle all of it at once and not just be a one function at a time or one operation at a time. But we're going to go through and plug all this in to calculate it. Then, after we calculate it, we'll take the square root to figure out what B equals. So, go ahead and pull out your calculator. Please make sure that your calculator is in degree mode. So either see if the DEG is indicated on your calculator, or go to mode, or wherever you have to on your calculator, and make sure that you're in degree mode. If you are in degree mode for 14.1 and your calculator hasn't reset overnight, then you will be in degree mode. So let's go through and calculate this. So it's 5 squared plus 7 squared minus 2 times 5 times 7 times cosine 100. So I went through and plugged all that in at once, and if we do it correctly, we should get 86.15537 and so on. So B squared is going to equal 86.155. Now that I know what B squared equals, to figure out the length of side B, all we have to do is just get rid of this power of 2. So that means all we have to do is just take the square root of both sides. So if we take the square root of both sides, we're going to get B on the left, and then we take the square root of 86.155. We're going to end up with 9.28, and if we round to the nearest tenth, we should get 9.3 for the length of side B. So that means B is 9.3. And that is how you use the law of cosines to find a side length. All right, so that is the first part. We had to go through and find the length of B. now that we have all three side lengths figured out, we can go through and figure out the angle measures of A and C. So again, while my temptation would be to go through and figure out the angle measures, you cannot find the angle measures using the law of sines unless you know all three side lengths. Okay, because if we look at the angle measures part of the law of cosines, okay, you have to know the length of side C, A, and B to go through and do that. So we accomplished our first task, which is figuring out the length of B. So now that we know the length of B, all we have to do is just choose whether we want to figure out C or A first. Doesn't matter which one you start with. Because the law of cosines that I have up here is in terms of C, let's go ahead and do it in terms of that first. So let's go through and figure out the measure of angle C. To figure out the measure of angle C, and I can bring this one down easier, it's cosine C equals C squared minus A squared minus B squared all over negative 2AB. So if we're going to set it up, it's cosine C, because we don't know the measure of angle C yet, then it's C squared. The side C is opposite angle C, so the side opposite is 5, so it's 5 squared, and then it's minus A squared minus B squared, so side A is 7, so it's minus 7 squared, minus B squared, well, the side B is 9.3, all over negative 2 times AB. We know A to be 7 and B to be 9.3. All right, so we now have it set up. So we have cosine C equals 5 squared minus 7 squared minus 9.3 squared over negative 2 times 7 times 9.3. So what we need to do is go through and calculate what this is. So we'll get cosine C equals something. Then, like we've always done, to figure out an angle measure, we're going to take the inverse of cosine to figure out what the measure of angle C is. So we're going to go through and calculate this fun fraction on the right. So we're going to do, I'll go through and put the top part in parentheses, or we can just calculate the top part and then divide by the bottom part. So let's do that. Let's do 5 squared minus 7 squared minus 9.3 squared. And we end up with negative 110.49. And we're going to divide that by negative 2 times 7 times 9.3. And when we go through and calculate that, we get that's not what I wanted. So let me go through and do this again. So let's put the top part in parentheses. So if we do 5 squared minus 7 squared minus 9.3 squared, end parenthesis, divide, parenthesis, negative 2 times 7 times 9.3, we get, there we go, 0.8486. So we're just going to go ahead and round this to 0.85. So we're going to do cosine C equals 0.85. So then to figure out what the measure of angle C is, we're going to do C equals cosine inverse of 0.85. And that is going to tell us the measure of angle C, which, if we do that in our calculator, second cosine, so cosine inverse, 0.85, and we figure out the measure of angle C, we get 31.78 if we're rounding to the nearest degree. 0.7 indicates that we need to round up, so that should be 32 degrees. So now that I know the measure of angle C being 32 degrees, all we have left is to figure out the measure of angle A. So we know all three side lengths, we know two angle measures, and whenever you know two angle measures, you can figure out that third and final angle measure by using the triangle angle sum theorem. So 180 minus the other two angles. So at the bottom here, if we do 180 minus 100 minus 32, we end up with 48 degrees for the measure of angle A. And that tells us all of the information we need to know for triangle ABC. So we've now found all three angle measures and all three side lengths for this problem. So key thing to note, when you are given two side lengths and one angle measure, you have to find the third side length first, like we did here in red. Once you have found the third side length, then you can go through and find the other angle measures. You need to use the law of cosines, the part to find angle measures, to find one, and then you can use the triangle angle sum theorem to find the third and final one. So that is how we do example 1, part A. Next, let's take a look at example 1, part B. So for part B, we have triangle ABC again, but this time they tell us all three side lengths and they do not tell us any angle measures. So if you're in a situation like this where they tell you all three side lengths but no angle measures, this is what you need to do. You need to go through and find two angle measures by using the law of cosines. So we're going to go through and use this formula twice to figure out angle C and angle A, or C and B, or B and A. So you're going to use the law of cosines to find two angle measures. Once you know two angle measures, you can use the triangle angle sum theorem to find that third and final measure. So with that said, for part B, we know all three side lengths being 10.5, 6.3, and 12. And we need to figure out the measure of angle A, B, and C. Does not matter which angle you start with, whether you want to start with angle A, B, or C. I'm going to start with angle C because, again, the way this is set up, it's nice to follow for setting this up the first time. All right, so law of cosines to find the angle measure, it's cosine C. So we're going to try to figure out the measure of angle C. So cosine C equals C squared minus A squared minus B squared. So the side C is the side opposite of angle C, which is 12. So it's going to be 12 squared minus, and then it's the other two, so 10.5 squared minus 6.3 squared. So now that I have my top part set up, the bottom part is just negative 2 times AB, which is going to be 10.5 and 6.3. All right, so now that I have that set up, I'm going to slide it back up. We are going to go through and calculate this fraction again. So we're going to figure out what cosine C equals, and then we're going to take the inverse of cosine of that number to figure out the measure of angle C. So if we go through and calculate it, again, I'm going to use parentheses for the whole top part. So parentheses 12 squared minus 10.5 squared minus 6.3 squared, end parenthesis, then divide, and we're going to do parenthesis negative 2 times 10.5 times 6.3. And when we do that, you should get 0.0448. So we're just going to write this as 0.04. So the cosine of C equals 0.04. Now, if you're leery about typing all that into your calculator at once, you can go through and calculate the top part and then divide it by the bottom part. My mistake when I did it for part A is with the negative sign. Okay, my calculator reads that differently and it read it separate. So if we went through and did that, we did 12 squared minus 10.5 squared minus 6.3 squared. And we would end up with negative 5.94. And if we divide that by parenthesis, negative 2 times 10.5 times 6.3, you get the 0.04. So the issue I had when I did that on part A is I didn't put parentheses around the bottom part, so it read the negative 2 as something different from the 10.5 and 6.3. Parentheses are your best friend. Okay, it's okay to use parentheses and you can never use too many. Alright, so now that we have cosine C equals 0.04, to figure out the measure of angle C, we're going to go through and take the cosine inverse of 0.04, and we end up with 87.7. So 87.7 would indicate that I need to round that up to 88. So that tells me that C is 88 degrees. All right, now we have one angle measure. We now have to find a second angle measure using the law of cosines. Does not matter whether we do angle A or angle B. For matter purposes, we'll just use angle A. So we're going to set it up similar to how we did for C. So it's cosine A equals, we're going to start with the side opposite angle A, which is 10.5. So whenever you are setting up the law of cosines to find an angle measure, okay, you want to start with the angle that you want to find. So in this case, we want to find A. So it's cosine A equals, and then you start with the side opposite of that angle. Okay, so just like with cosine C, to find the measure of C, we started with the side opposite of C, which was 12, so 12 squared. So whatever angle you're trying to find, when you start the right side, you start with the side opposite that angle, and then the other two just fall in line behind that. So it's 10.5 squared minus 12 squared minus 6.3 squared over negative 2. And then we don't worry about the 10.5 anymore. We just worry about the other two numbers. So times 12 times 6.3. So now that I have that, all we have to do is just go through and calculate. So we're going to do 10.5 squared minus 12 squared minus 6.3 squared, and we end up with negative 73.44. So then we are going to divide by this negative 2 times 12 times 6.3. So divide, parentheses, negative 2 times 12 times 6.3, and end parenthesis, and we get 0.48 0.57. So we're going to round this to 0.49. So cosine A equals 0.49. So to figure out the measure of angle A, we're going to take the cosine inverse of 0.49, and that's going to tell us, second cosine, 0.49, that the measure of angle A, we get 60.659, so we're going to round that up to 61 degrees. So now that I know that the measure of angle A is 61 degrees, that successfully tells me 2 out of 3 of the angles. So to figure out the third and final angle, we're going to just do 180 minus those 2. So we'll do that in the calculator. So 180 minus 88 minus 61, and we end up with 31 degrees for the measure of angle B. So if we want to write that down, just kind of slide up. The measure of angle B equals 31 degrees. And I have successfully found all 6 parts of this triangle, and most importantly, found all 3 angle measures, and they only tell me all 3 side lengths. So, example 1, part A, is going to be what you need to reference when they tell you 2 side lengths and 1 angle measure, how you go through and solve that. Okay, just as a refresher, if you're given 2 side lengths and 1 angle measure, you need to go through and find the third side length, then you can go through and find the angle measures. Okay, you have to know all 3 side lengths before you can find an angle measure. To find a side length, you just need to know 2 side lengths and 1 angle measure to help you find that side length. Now for part B, we already knew all 3 side lengths, so that meant we can go ahead and find the angle measures. Whenever you know all 3 side lengths, you have to use the law of cosines twice to figure out 2 angle measures, and then you can use the triangle angle sum theorem to find that third and final angle measure. So, with that said, that completes parts A and B of example 1. Now, parts C and D are going to have you do the same thing, where they have you solve for each triangle, whether it's part C or D. The difference is they do not have your triangle drawn. They just tell you what side B and side C equal and the measure of angle A. And then for D, they tell you what side A, B, and C equal, and they do not tell you any angle measures. Parts C and D, you're going to run through just like you did with part A. There's just no diagram to reference. Now, to save time, I'm not going to run through these full in detail. My goal would be to try to provide you problems that have the diagrams. But if we were to talk about these real quick, okay, if we look at C, for part C, they tell us 2 side lengths and 1 angle measure. So that means we have to find the third side length, which is A. So use the full-on law of cosines. So you would take both of these side lengths and then use the measure of angle A. So you get 23 squared plus 18 squared minus 2 times 23 times 18 times cosine 173. Plug it all in, take the square root, and you would get the measure of A to be 40.9. Once you know all 3 side lengths, A, B, and C, we can go through and figure out the measure of angle C or B by using the variation of the law of cosines to figure it out. Plug all that stuff in, all 3 side lengths, then take the cosine inverse, and we find that angle C is 4 degrees. And then once we have 2 angle measures, in this case angle C and angle A, we can figure out angle B by doing 180 minus the other two. So this part C is just like part A, for example 1, just like part D is just like part B. So part D, just like part B, they tell us all three side lengths. So we need to go through and find all three angle measures. So to do that, we go through and use all three side lengths in that part to find angle measures. So you do c squared minus a squared minus b squared all over negative 2ab. You get a result. Take the cosine inverse. That tells you an angle measure. Run through that again for another angle. So a squared minus b squared minus c squared all over negative 2bc. Cosine inverse, we get angle A to be 43 degrees. And then we can use triangle angle sum theorem to figure out the measure of angle B. So, with that said, that really pretty well sums up everything for the law of cosines. Really left for example 2 is just some story problems. You can reference those in my completed notes, or you can pause and take a look at those right now. You're just using the law of cosines to figure out the length of a side length of a triangle. So here you have to go through and figure out the distance. So you would use 3 and 4 and 71.7. Plug it into the law of cosines. For B, you're trying to figure out how far it is from the turning point to Oklahoma City. So you use the law of cosines in 175, 396, and 28 degrees to go through and figure out that length right there. So I will leave those ones for you to reference in case a story problem pops up on the homework. Otherwise, that is it for today's lesson on the law of cosine. I really do highly recommend that you reference the completed notes or come back to the video. Be sure to look at example 1A and B. I know I spent my entire time talking about both parts A and B, but those are the two examples you need to guide you through your homework. Okay, part A takes us through how to find all the different missing parts when you know two side lengths in one angle measure. B shows us how to go through and find all three angle measures when all we know is all three side lengths. These two right here are extremely helpful and extremely important as you go through your homework. So be sure to come back and reference the completed notes so that way you can look at the law of cosines, both to find side lengths and angle measures, because these formulas are extremely helpful, and then have it for your examples. So, with that said, that is it for today on our lesson for section 14.2, the law of cosines. Okay, just like with 14.1, if you need help, which you might, please do not hesitate to reach out. Whether the next time you see me, ask me for help, or just shoot me an email and I'll be more than happy to help however I can. Otherwise, please be sure to reference this video or the completed notes or any other resources to help you through the homework. Otherwise, that is it for today on the law of cosines. Thank you guys for listening. I hope this was helpful. Please do not hesitate to reach out if you need help. Be sure to look at the completed notes. Otherwise, that is it for today. Thank you guys for listening. Have a great day, and I'll talk to you later. All right, bye.